Hello students, in the GATE computer science syllabus we are learning the first topic in the subject of computer networks, which is the concept of layering. In the last video we saw about basics of a computer network. So what is a computer network, what are the components needed for a communication, then what are the types of link between two computers, and then what are the categories of a network like local area network, wide area network. Then we learned about simplex, duplex, half duplex, full duplex, etc. And so in this video we will be discussing about MANET and then network topologies. So the bus topology, star topology, ring topology. Now let's start. A MANET stands for Mobile Ad Hoc Network, which is also called a wireless ad hoc network or an ad hoc wireless network. A MANET consists of a number of mobile devices that come together to form a network as needed without any support from any existing internet infrastructure or any kind of fixed stations. For example, if you are standing in your school assembly, like you have to follow a set of rules, like you have to leave one arm gap space between two students, and then short students should stand first and then tall students should stand at the end. So but while during the break time, when you are chit chatting with your group of friends, with your gang members, so you may not follow a predefined rule like this. You will be standing in any position, random position that you like, maybe in a circle or just any random position. MANET is similar to this, like the nodes form together, random nodes will come in together in the area and they will form a network randomly. No predefined infrastructure is needed. A MANET can be defined as an autonomous system of nodes connected by wireless links, the union of which forms a communication network modeled in the form of an arbitrary communication graph. In a MANET, no such infrastructure exists, no infrastructure is needed to form a communication, and the network topology may be changing dynamically in an unpredictable manner since the nodes are free to move and each node has a limited transmitting power, restricting access to the node only in the neighbor range. So each node in a MANET have its own communication range. So a node can only communicate to the nodes which are within this range of that particular node. So each node will maintain a neighbor table, like which are the nodes that are within its communication range, so that it can forward the data to that neighbors. So consider this as node A and this as node B. If node A wants to transmit data to node B, it will check its neighbor table whether it is within the communication range of node A. It must not be there. So, but within the communication range of node A, it has nodes I1, I2, I3, I4. So, assume these four nodes are within the communication range of node A. So, in order to communicate the data to node B, it will check the neighbor table and it will send the data to the intermediate node I3. Then the intermediate node I3 will pass data to the intermediate node I5, and then through I5 the data will reach node B. Since this is a MANET, the node's position may be changing randomly, right? Node B won't be staying here all the time. It can move to this position or any position after a particular point of time. So while transmitting data, the nodes follow a store and forward technique, which means each node, if node A is sending data to the intermediate node I1, what I1 will do is it will have a local copy of the data which is sent by node A, and then it will send the data to node I3 while transmitting the data to I5. So while transmitting the data to I5, it is no guarantee that I5 will stay here all the time. I5 may move to a different location, say here. So if it is moving to a farther distance, I5 may be far away from the node I2's communication range. So packet drop may happen. So the message may get lost, the data loss happens. The data won't be delivered to I5 successfully. So in order to cope with the failure, what node I2 will do is it will have this local copy. It will use this local copy and send it to some other neighbor from which the data will reach the final destination node, like node B. The store and forward technique works by storing the message transmitted by the source device on an intermediate device, generally a server. The intermediate device then locates the destination device from its database of subscribers initiates a connection and transmits the data packet that was originally sent by the source device. The store and forward is implemented in scenarios where subscribing devices are geographically distant, lack in direct connectivity, or where the network is experiencing high error rate. As the nodes move, the connectivity may change based on relative location of other nodes. The resulting change in the network topology, known at the local level, must be passed on to other nodes so that the old topology information can be updated. For example, when a particular node A in a MANET changes its point of attachment from node I2 to I3, the other nodes that are part of the network should know this new route to forward packets to node A. We assume that it is not possible to have all nodes within each other's radio range. In case all the nodes are close by within each other's radio range, there is no routing issue that need to be addressed. There is yet another issue, that is of symmetric and asymmetric. Symmetric is usually bidirectional. Asymmetric can be bidirectional as well as unidirectional. Consider symmetric link with associative radio range. For example, if node A is within the radio range of node B, then node B is also within the radio range of node A. So if node A can send data to node B can also send the data to node A. The communication links are symmetric. This assumption is not always valid because the transmission power levels may differ and the area in which the nodes are located may also differ. Routing in asymmetric network is a relatively hard task. In certain cases, it is possible to find routes that exclude asymmetric links. Since it is difficult to find the written path. The issue of efficiency is one of the several challenges encountered in MANET. The other issue is varying the mobility pattern of different nodes. Some other nodes are highly mobile while others are primarily stationary. It is difficult to predict the node's movement and direction of movement. Numerous studies have been performed to evaluate their performance using different simulators. A MANET can operate in a standalone fashion or they can be part of a larger internet also. They form a highly dynamic network topology with the presence of one or multiple different transceivers between nodes. The main challenge for the MANET is to equip each device continuously to maintain the information required to properly route the traffic. MANET consists of a peer-to-peer self-configuring, self-forming healing network that can communicate at the radio frequencies of 30 MHz to 5 GHz. So this is the communication range of a typical MANET network. So this can be used in road safety, ranging from sensors for environment, home, health, disaster rescue, and air or land, navy defense, weapons, robo, etc. The main characteristics of MANET can be, the first one, dynamic topology. The nodes are free to move arbitrarily. Thus, the network topology may be changed randomly and unpredictably, which consists of bidirectional links. In some cases, when the transmission power of two nodes is different, a unidirectional link may exist. So if the device belong to multiple configuration, like belong to different category, they may have a unidirectional link. But if both the devices belong to the same category, like the same configuration, then there can be a bidirectional symmetric link between them. It all depends on the type of mobile device that is used in the network. The second is bandwidth constrained. So these network has variable capacity links. Wireless link usually will be having a low reliability, low efficiency, low stability and low capacity when compared to wireless network. Third is autonomous behavior. So each node can act as a host as well as a router, which shows in its autonomous behavior. So what do you mean by a node can act as a host as well as a router? So typically in a wired network, what happens is your intranet, inside your college intranet, there will be so many computers that are connected. So with the help of that intranet, they can communicate among those nodes. But if any particular node in your college area in your intranet wants to access the Indian bank server or any outside server, they can't communicate directly. They will just send the data to the router, to your internet router, and with the help this router only can pass the data to the Indian bank, and after getting the response from Indian bank, the router will process it and send it to the node which is inside your college intranet. So this node cannot access data from the external network directly, but this case never happens in MANET. So each node is capable of communicating with other nodes provided the node is within the communication range of that node. If it is not within the communication range of the particular node, it will use intermediate nodes, and with the multi-hop technology it will reach the destination node. No predefined rules for that. The fourth is energy constraint operation. So since most of the nodes rely on battery or other exhaustible means for their energy, mobile nodes are characterized by, as most are the nodes rely on batteries or other exhaustible form of energy. Mobile nodes are characterized by less memory, less power, and lightweight issues. The fourth is, next one is limited security features. So these wireless networks are prone to security threats mainly because the centralized firewall, just like the college setup or a wired setup, is missing here. So there needs to be measures to ensure security, routing, and host configuration, etc. The final thing characteristic is less human intervention. So these manets, they require minimum human intervention to configure the network. So just we noticed earlier, this is a completely self-configuring network. So they are dynamically autonomous in nature. The advantages of MANET include separation from central network administration. So these nodes are completely independent, no central authority, etc. Then second is, each node can play both the roles of a router as well as a host, which shows its autonomous nature. Third, each node is self-configuring and self-healing, so it don't require any human intervention. The drawbacks of a MANET may be the resources are limited due to various constraints like noise, interference, etc. And there is no proper authorization facilities, and also the nodes are prone to attacks due to limited physical security. Applications of MANET. So there are a few areas where MANET can be applied. For example, in defense applications it can be used, like on the fly communication setup and ad hoc networks are excellent candidates for use in battlefield management. The second is crisis management application. So these arise, for example, as a result of natural disasters in which the entire communication infrastructure is in disarray. Restoring communication quickly is essential. In such a situation, MANET can be extremely useful. The third is telemedicine. Maybe the paramedic assisting the victim of a traffic accident in a remote location must be able to access the medical records, for example X-ray or anything, and may need video conference assistance from a surgeon or for an emergency intervention. In fact, the paramedic may need to instantaneously relay back to the hospital the victim's X-rays and other diagnostic tests from the site of the accident. So just like you have seen in some movies, like through video conference, the doctor will take care of the patients online, like it's just telemedicine. Fourth one is tele-geo processing application. It is just a combination of GPS and GIS, like geographical information system, with which high capacity wireless mobile system enables a new type of application which is called the tele-geo processing. Then fifth one is virtual navigation, like a remote database which contains the graphical representation of buildings, streets, and physical characteristics of a large metropolis. They can also virtually see the internal layout of buildings which includes emergency rescue plan or find possible points of interest. Then education via internet. Educational opportunities available on the internet or remote areas because of the economic infeasibility of providing expensive last mile via line internet access in these areas to all subscribers. Finally, vehicular area network. So this is a growing and very useful application in wireless ad hoc network which provides emergency services and other information. This is equally effective in both urban and rural setup. The basic and exchange necessary data that is beneficial in a given situation. Next, looking at the types of MANET, the first one is vehicular ad hoc network. This vehicular ad hoc network enables effective communication with another vehicle or with the roadside equipments. The second category is smartphone ad hoc network. This is used to create a peer-to-peer network without relying on cellular carrier networks like your Airtel or BSNL, etc. So without any wireless access point or traditional network infrastructure, the peers can join or leave the network without destroying it. The third is internet-based mobile ad hoc network. This supports internet protocols like TCP, UDP and IP. We'll discuss about this in the upcoming videos. And it also can be used to link mobile nodes and establish routes distributed and automatically. Next category is the hub and spoke MANET. The multiple sub-MANETs may be connected in the hub-spoke VPN to create a geographically distributed MANET. Normal ad hoc routing algorithm does not apply directly. So you might have heard about the hub and spoke model. Hub and spoke model is actually hub can be a central repository or some central node, and the spoke nodes will be reliant on it and connected to it, just like consider a cycle wheel. A central element will connect all the all the components of the wheel with which the wheel can rotate successfully. So or you can consider one more, or for example consider a bank. If it has so many branches throughout the nation, but for each state it will have a regional office, and for each district or each circle it may have a circle office. Like this acts as a hub to all the branches around that village, and this is the one. This can be considered as a hub, and the regional office can be considered as the hub for all the branches in that particular state. Hub spoke model works in such a manner. And then is for military or tactical MANET. So this is used by the military units. So and emphasis on data rate, real-time demand, fast rerouting during mobility, security, radio range, etc. So final category is flying ad hoc network. This is usually composed of unmanned aerial vehicles, so which are known as drones. The drones are popular these days. So these drones provide links to remote areas and mobility. Usually when we are transmitting data from a source node to the destination node, the data will pass through these 7 layers of the OSI model. So when the data passes to the physical layer, it will be called as a bit or signal. So and then when it goes to the data link layer, it will be called as a frame, and finally when it reaches the network layer, this data will be called as a packet, and in the transport layer, data will be addressed as a segment. In the physical layer is mostly concerned with the physical transmission, like the physical wires, hardware part, etc. In the data link layer, the data will be called a frame. So in order to transmit data between two devices in the data link layer, one needs to know the MAC address of the device. MAC address is nothing but a unique address that is owned by each and every device. Like our laptop and PC each has its own MAC address. MAC address can't be changed. It is fixed throughout the lifetime of the device, and then when the data passes through the network layer, like it will be called a packet. So in order to transmit data between two nodes in the network layer, one needs to know the IP address of the source and destination node. IP address is nothing but IP address is a unique address that is assigned to your device whenever you connect to a network. So this IP address may differ for each network connection, like it is dynamic, but the MAC address you have, it is fixed throughout the lifetime of the device. And then when the data passes to the transport layer, it will be called as a segment. And just we'll go into this detail while discussing about the OSI layer models. But as of now, just remember, in the data link layer, data will be addressed as a frame. In network layer, it will be addressed as packet, and we need IP address. In data link layer, we need a MAC address, and in the transport layer, data will be called as a segment. So so in order to connect the network, we need a few devices like the router, hub, switch, etc. We can look into that now. First one is called the repeater. Repeater is actually a device that is used to boost the signal. For example, if I am speaking through mobile, the receiver cannot hear my voice. For example, if I am speaking, the people in this room alone can hear my voice clearly, but the people in the next room, they will be hearing my voice a little bit, like the signal might have gone weak, so they'll just hear my voice, but the words that I speak, it won't be clear. So in order to address that, the repeater is used in the middle. So the main goal of this repeater is just to boost the signal that is coming from the source device and regenerate the signal to the destination device. And the next one is each of these network devices like the router, hub, bridge, switch, etc. they will be having so many ports in them, they will be having like 2-port switch, 4-port switch, we call that. There will be a set of ports in each device. So when looking at the hub, what a hub does is it just connects multiple devices, like the devices with the help of their the ports they have. So we can connect a node A here, connect a node B here. So the main duty of the hub is just as a wiring center. It acts as a wiring center. It connects the devices together. And there are 3 types of hub. This one is active hub, then passive hub, and one is intelligent hub. The active hub, it acts as a wiring center as well as it acts as a repeater. So it boosts the signal and it cleans the signal, whatever frame it gets. An active hub would just boost the incoming frames, and it would make the signal clean and clear when it is transmitting to the receiving device. So active hub is a wiring center plus a repeater, but the passive hub, it acts just as a wiring center alone. It won't do the repeating, boosting parts and all. The third thing is intelligent hub. Intelligent hub is the same as active hub. In addition to that, this intelligent hub will have an administrator. The main goal of this administrator is just to monitor the traffic, incoming traffic and outgoing traffic, what frames are going through the hub, what frames are transmitted through the hub. It will just monitor the frames that are moving to and from the hub actually. The next one is bridge. Normally a bridge is used to connect 2 different LAN areas. Like similarly, a bridge is used to connect 2 different local area networks actually. 2 local area networks is usually connected through a bridge. A bridge is also a layer 2 device. Hub is actually a layer 1 device, like operates in the physical layer actually. So coming to the bridge, it usually connects 2 devices, and there are two devices that belongs to 2 different LANs, and there are one type of transparent bridge, and second one is source routing bridge. So what transparent bridge does is, this bridge will have multiple ports, right? One port will be the bridge will be having multiple ports, right? Like one device would have been connected to that port. This transparent bridge, what it will do is it will just learn but what a hub will do is that if a node in port A sends data to the hub, it will just forward data to all other ports in the network, but a switch will only forward the frame to the particular corresponding port alone. So this is an intelligent LAN hub actually, since it's a layer 2 device. So switch is similar to the router is similar to switch, but switch operates at layer 2. It deals with MAC address, but router operates at layer 3. It deals with IP address. So it has an IP address table, like in each port which which devices are connected, what are their IP address, they will be having these details. So if a node A in this port wants to communicate data to node B in this port, so each node should know each node should have its own IP address. The source node should know the IP address of the destination node, so that it can transfer the data to the destination actually. The next one is a router. Router is a combination of bridge plus router. So it does two functions mainly: the operation of a bridge, which is a layer 2 device, and the router, which is a layer 3 device. It does two functions of layer 2 and layer 3 as well. Then gateway connects networks, two different networks that follow completely different network protocols actually. Consider you are in India speaking a particular language, and people in Gulf countries will be speaking a particular language. In order to mediate the communication between two language speaking people, we need a translator or a mediator, translator, who will translate. Like if Indians speak in Hindi, and the translator will translate it back to Arabic and communicate it to the Gulf people, and the same thing happens vice versa. The gateway serves this purpose. It actually enables communication between two devices that follow completely different routing network protocols. And then finally we have network interface card. So this is a small chip. It will have a unique ID on it. This network interface card will be in each device, like your laptop or PC. Like this network interface card is mandatory if you want to connect your device to the internet actually. Before knowing about the network topologies, first let us see about the type of cables that are used in a network. There are 4 types actually: coaxial cable, shielded twisted pair, unshielded twisted pair, and fiber optic cable. Coaxial cable will usually be like coaxial cable is normally used in typical the cable TV network actually. So there will be a copper filament in the middle. So after that it will be surrounded by actually plastic layer, plastic coating, which will be insulated by a metal filament actually. So there are 3 layers. Middle element is the copper one, and then it is surrounded by a plastic one, and then which is again surrounded by a metal filament. So this is a typical coaxial cables configuration actually. And then comes unshielded twisted pair and shielded twisted pair. This twisted pair is actually like two cables are twisted in in pairs. Like 2 wires will be arranged in shielded twisted pair. In unshielded twisted pair, 2 wires are twisted actually, and they are mounted as it is. That means it is unshielded twisted pair. In shielded twisted pair, 2 wires will be shielded, twisted, and it will be protected by a filament actually, external filament. So this layer prevents the network from interference actually. So for critical applications we use shielded twisted pair, because since the shielded wires are protected by a filament additionally. Then the final category is fiber optic cable. In fiber optic cable is the fastest type of cabling so far. It has a glass layer actually. It is surrounded by a plastic layer. So the outer one is a plastic layer and the inner one is glass. So in these 3 types of cable, data will pass in the form of electrical signals. But in fiber optic cable, data will pass in the form of light. So it is faster than electrical signal, and there is no chance of interference also. Interference is extremely low. Nowadays internet connection is mainly based on fiber optic actually. It is extremely effective. A topology is nothing but a layout actually. Network topology means there is actually a network of nodes that are connected. Topology describes how the nodes are located actually, what is the location of each particular node, what particular format they are using in order to establish the connection. That is what described in the network topologies. Actually there are a few types of topology like the bus, star, ring, tree, mesh, etc. So first let us see about the point-to-point topology. In point-to-point, in the last video we mentioned like a one communication link will be there. It will be shared between only 2 nodes. So this is a typical point-to-point network topology actually. So point-to-point topology is mainly used between a TV and a remote. So there are only two nodes that are involving in the communication. There is only one communication link actually. So in the point to point, the mode of data transmission can be either simplex or half duplex or full duplex. It depends on the the application area actually. Between TV and remote, it will be simplex usually, because remote will be sending data towards the TV monitor. The monitor will respond actually in the screen alone. It won't send back any signal to the remote. So it is like simplex unidirectional data flow. Then comes bus topology. In bus topology, that's actually a backbone cable to which all the nodes in the network are connected. So if one node wants to communicate data, if you want to transfer data, that data will be loaded to the backbone wire, and this cable, what will it do? It will transfer the data to all other nodes that are connected to the bus actually. So in order to access the bus, or in order to transfer data, so each node should follow a access protocol like CSMA. There are two types: collision detection and collision avoidance. CSMA means carrier sends multiple access. Carrier in the sense, like if you are using mobile data, what is your carrier network actually? Either it is Airtel or BSNL or whatever service provider whom you are subscribed, that is your carrier network. Similarly, carrier sends multiple access in the sense each node detects its carrier node, whether it can transfer the data, it is available to accept its data, etc. So in collision detection, in the sense, if one node wants to transfer data, it will just check the backbone cable or the bus, whether there is any data flow actually, or if the bus is idle, it will be ready to transfer its data. This is called collision detection. Then collision avoid. In order to avoid the collision, like collision avoidance, what each node does is, before they are transmitting the data, they will just check on the bus whether it is idle or not. So if it is idle, if it is some data is getting transmitted through the bus, this node will wait for a predefined time limit. So in order to avoid the collision. But if the node, if now at a particular point of time, if this node has started transmitting data after sensing that the bus is idle, and this at the same time this node has also checked on the bus and the bus is idle, now they both are transmitting the data. So at a particular point of time, these two nodes, these two data come into contact with each other and collision occurs. Once they have detected this collision, what both the nodes they will do is, they will just back off, they will stop transmitting the data, and they will wait for a predefined amount of time, like the back off period. These will be discussed in the later videos. Like after that back off period, the node will again sense the bus and then again start transmitting. Advantages of bus topology include, these network topologies are actually cost effective and suitable for small networks due to simple layout. Then all these devices are connected through a coaxial cable or RJ45 cable, and then additional nodes can be added easily if required just by connecting extra cables. And then installation is actually easy, and every cable requires to be connected through a single cable alone. Then when compared to other networks, a few cables are actually needed. Then talking about the limitations of bus topology, it includes the single cable used in this network is somewhat exposed kind of thing. So if this bus cable it is damaged, the whole network can go down. That's pretty bad. Then these networks are not suitable for the networks that have a huge traffic, because when one node is transferring data, the bus, what will it do? It will send the data to all other nodes in the network. So if all the nodes are transmitting data actually, it will increase the traffic and increase the load actually. Then another drawback is the wide cabling. Extensive cabling is used here, and troubleshooting becomes difficult due to it. Then signal interference is quite common. Collision occurs quite frequently. Then reconfiguration is quite difficult, and then attenuation issues are there. Attenuation means data loss happens frequently due to these collision issues. Then talking about applications of bus topology, it is mainly used for local area network where the nodes are connected through the thinnest cable, and These topologies are mainly applicable once a small and temporary network is secured, which won't depend on any extremely high speed data transfer. They are also used in office areas and laboratories. Next, we can talk about ring topology. Ring topology is similar to bus topology, but in addition, the nodes in the ring they are connected. Actually, in the bus topology, every node will be connected to the bus central backbone cable. Actually, this node won't have direct connection between them, but in ring topology, two nodes are connected like in a circular fashion. This ring topology won't have like a particular like the source node, destination node. No, there will be no particular beginning and end. It operates completely in a circular fashion. And one more thing, data flow actually happens in unidirectional, mainly clockwise flow of data. So in order to facilitate anti-clockwise as well, so additional cable, like just what is mentioned here, like additional two cables need to be established between two particular nodes. So one is for clockwise data flow, one is for anti-clockwise data flow, but typically only one directional data flow will be present. So data transmission happens in the form of token passing. Actually, token is nothing but the data which we want to send. Token is nothing but the data which has to be transmitted. Consider this node A. This wants to transmit data to this particular node, which means this node will create a token. Token is nothing but the data it has to transmit, and then it will pass the token to its neighbor. So this node will check whether this token is intended for this. It will check whether the destination address is their address actually. So it is wrong. So then it will just pass the token to its neighbor in clockwise direction. The token gets passed until it reaches the proper destination node, after which the destination node will see the packet. It is intended for this particular node only. After that, it will send acknowledgement. That too will be passed in a circular fashion, and it will reach the original source node. The advantages of ring topology include network management, then availability of the product, less cost, reliable, then installation is easy, and then managing is easier for adding or removing a device from the ring topology, since only two links are needed to add or remove a node actually. So then talking about the drawbacks, we have it will be difficult to troubleshoot, and the network failure can happen due to a breakdown in one particular station. Reconfiguration is also not that easy, and we may have communication delay. So if this node wants to transmit data to actually this node, they both are neighbors, but since there is only unidirectional data flow, this data packet token has to travel the entire network in order to reach this neighbor. So data traffic issues can occur when all the data is moving within a ring. Then applications of ring topology may be like ring topology is used in a local area network and wide area network. It is also used in educational institutions due to its low cost of operation. Then we can discuss about the star topology. In the star topology, there will be a central hub to which all the nodes, all the devices will be connected. We discussed about the hub and spoke model, right? Something similar to that actually. So it is easier actually because adding nodes is easy, and because we just need a link and the node can be added actually. So the advantages maybe adding nodes is easy, it is cost effective, it is actually very much flexible. So even if one node gets disconnected, the network won't be troubled because the other nodes can communicate as usual actually. Only this node will be removed from the network. Then the drawbacks means configuration is difficult. It's difficult to set up. It is also using coaxial cable only or RJ45. Once the hub node is compromised, then the network falls down actually. That is the main issue in star topology. Then the application of star topology include the star topology can be used in different locations because it's readily available, as well as it is very cheap equipment. In most of the colleges, this technology is used in their computer labs for connecting different nodes. Also in bank sectors, this topology is used to connect different banking users. Home networks can also be connected using this topology. Next comes the tree topology. Tree topology is actually a combination of star topology and bus topology. The nodes in the network are connected in a hierarchical manner. Each node has a parent. It follows like a parent-child relationship. In star topology, it will be like these nodes are the client nodes and this is the server. Like so, star topology follows the client-server setup. Tree topology follows the parent-child setup, hierarchical fashion. So one link has to be connected between two nodes. So each node share a single communication link. Two nodes share a single communication link in order to transfer data actually. Tree topology is actually very much efficient and commercial actually. It is mainly used all corporate networks use this tree topology because adding new nodes is very easy actually. It does not face any scalability issue because new nodes can be added at the leaf level. So it is very much convenient. The drawback can be it is very much expensive because so many cables are required and constant monitoring of the network is also required because if there is any fault it has to be configured immediately. So critical serious so we need to monitor the network continuously. Yeah, the tree topology is mainly used in all corporate IT offices use this tree topology. Then talking about the mesh topology. Mesh topology is it is just like each node can act as a host as well as a router. Like each node has connection to every node. It's like it follows a multi-point peer-to-peer architecture. It's just like a peer-to-peer network actually. So in mesh topology, there are two types like full mesh and partial mesh. So in full mesh, if each node in the network will be connected to every other node in the network. For example, if there are n nodes in the network, there will be n into n minus 1 by 2 edges. Like each node will be connected to every other node. Like it's a complete like full mesh. But about in partial mesh, it is not a rule that each node has to be connected to all other nodes in the network. But redundant links are possible here. That's why the term mesh actually. In the advantages of mesh topology may include, since there are so many redundant links, even if one particular link fails or if a particular node fails, the network can actually handle the issue. Like since there are redundant link between two nodes, it can handle the issue and the network can operate successfully even in case of failure. Drawbacks can be so many extensive cabling is required, like additional unwanted links, so many unwanted links are present. Then applications of mesh topology include like this mesh topology can be mainly used in like business critical applications where data losses can't be acceptable, like no data the data should not get lost. It is we are dealing with very sensitive data. For example, when traffic flow with the police control etc. for these sewage treatment, for these critical applications, mesh topology is used. There is one more topology like hybrid topology. Hybrid topology is nothing but a combination of all the topologies which we discussed, like just like how we said, like tree is a combination of star plus bus. Just like that we can combine star, bus and mesh and form a new topology. That's what a hybrid topology. Hybrid topology is usually required when we need to customize our own topology as per the requirements of our business. Next comes daisy chain topology. Daisy chain topology is similar to a normal chain which we wear, like not in latest model, like in some chain usually like it will be two nodes will be connected like in a point-to-point fashion, like just like that. In daisy chain, a single node will be connected to its neighbor, then which in turn will be connected to some other neighbor, like in a point-to-point in a linear fashion. The nodes are connected. Actually, in daisy chain there are two types. One is a linear chain, linear daisy, and the next one is ring daisy. In linear daisy, just like a normal chain, it will have a particular start end and a start terminal and end terminal, and the nodes are connected in a linear fashion. But when talking about ring daisy, the setup is actually closed. So this won't have any start terminal and end terminal. The nodes are connected in a circular fashion, like in a one particular direction the data flow will be happening. So when choosing a particular topology for your network, for your organization, actually we need to consider two things. First, we need to understand what are the topologies that are currently in practice, like get to know an idea about all the topologies. Then determine your business demand, like the requirement, and then customize a proper topology that tailors to your business requirement. Actually, don't just like take if other networks or other organizations are using a mesh topology, don't just try to tailor your business requirement as per the mesh topology. Instead, you can just customize your own hybrid topology based on your business needs.
Next, we'll be discussing the unique identifiers of any particular network. Like consider the host name. Host name is the unique name given to each device. For example, if you buy a laptop, you can configure the laptop with your own host name. Like the host name will be your name if it is your personal laptop, and it will be the college name if it is a laptop, or if it is a PC from your college lab. Actually, then comes the IP address. Actually, the IP address is a unique address which is assigned to your device whenever you want to communicate to connect with the internet. Actually, if you have if you are using the Airtel network to communicate to the internet, the Airtel service provider will generate you a different IP address. But if you are using your BSNL broadband or some other network, you may have a different IP address. So it depends on your service provider. Then comes the MAC address. Actually, MAC address is a unique address, like it is static. Usually it is pre-configured to every device, so each device has its own MAC address which cannot be changed in any situation. Like if you open and view the command prompt with the proper commands, we can use the MAC address. Then comes the port and socket. These are concerned with the transport layer. Actually, so just like how I discussed in the OSI layer, if multiple nodes are transmitting data, like for during communication, each in each layer data will be called using a different terminology. Like in physical layer it will be called as data or bit or signal. In the data link layer it will be called a frame. In the network layer it will be called a packet, and in the transport layer it will be called as a segment usually. So this port and socket deals with the transport layer usually. So socket address is usually a combination of port number plus the IP address. There are so many reserved port numbers, and like some port numbers are reserved, some port numbers are used for specific purposes. Actually, so to better understand the concept, let us give you an example. Actually, like if you are using your browser to access the internet, you may have opened multiple tabs right in your device. So in a particular tab, if you are accessing the Amazon server, like you may send any request to the Amazon server. Like if you want to view any particular product, or you have to purchase any particular product, so this request which you send to the Amazon server, it will contain a combination of your IP address as well as your port address. This combination will be sent to the Amazon server actually, and the Amazon server will view your request and it will respond back to you to your corresponding IP. This IP address will reach your with this IP address, the response can reach your laptop or in your device which you are accessing, and after that, with the help of that port number, the response will be corresponded or directed to that particular tab in which you are accessing the Google, Amazon server actually, Amazon web page. So port numbers are different for each session. It is mainly guarded by sessions actually. Next comes the dynamic DNS, which is the domain name system. The main aim of domain name system is to root is to map between the domain name and IP address actually. So each domain like google.com, facebook.com, etc., each domain will have its own IP address. So in order to receive or communicate with that domain, we typically we don't want to remember their IP address actually, because it will be very difficult, like because everything is online these days, we'll be accessing so many websites. So instead of just remembering the IP address, DNS helps us just by it does the mapping automatically. Like we just have to type google.com in our browser, and the DNS server, it will automatically map it to the IP address of google.com, and it will process our request, and it will send back the response to us. The DNS is extremely beneficial actually. Next comes the ARP. ARP is the address resolution protocol. Address resolution protocol is mainly used to transfer map between IP address and the corresponding MAC address. For example, if there are two devices like A, B, C and D wants to there are four devices in a network like A, B, C and D. So A has to transfer data to B. For that particular scenario, A has to know the MAC address of the corresponding node B. We don't know whether the node A and B are within the range of each other. So this node A don't know the MAC address of node B. What this node A will do, it will just broadcast the request to all its neighbor nodes, saying that hey, I have the IP address of this particular node. I just need to know the MAC address of the corresponding node in order to transmit the packet. Like it will send a request. So all the nodes will have a look at this request, and if they have the MAC address corresponding to that IP address, they will send a response back to the source node A actually. So with the help of that MAC address, this node A will communicate to the node B directly. But in reverse address resolution protocol, it is actually the opposite. It is just like mapping from MAC address to IP address. So with ARP we can map from IP to MAC address, and with reverse RARP we can map from MAC address to IP address. These ARP and RARP, they are extremely beneficial actually. You can make use of it. Usually in a network, in order to guarantee reliability, what we will do is we'll be using redundant links. For example, like we saw the mesh network, in mesh topology, multiple nodes will be connected. Like if there are a few nodes in a network, instead of establishing a single route between two nodes, there will be redundant link between multiple nodes, so that even if a particular link fails, with the other redundant link, the two nodes can communicate actually. In business critical applications where data loss is unacceptable, we can use redundant links. But when using redundant links, three main issues happen, which is the broadcast storm, then is multiple copies, and third one is MAC address stashing. Consider like a node X. Node X is a device and it is connected to the switch A. So the nodes that are within the range of a switch is called as particular segment A. So this switch A is connected to switches B and C, and the switches B and C are connected to switch D. Finally, the switch D is connected to the node Y actually. So the node Y within the range of switch D, it will form a separate segment. Usually in networks, we configure multiple switches actually, so many switches, in order to ensure reliability and to avoid data loss actually. So consider, if node X wants to send data to the node Y, actually it will just send the data to the switch A. This switch A will check the MAC address table of that particular switch, whether it knows the MAC address of the node Y actually, whether it is in its MAC address table. Actually it just checks. It never finds the MAC address, so it will just forward the packet to its neighbors, forward the frame to the neighbors B and C. So these neighbors B and C, they will be checking their MAC table, whether they have the MAC address of the node Y, so that they can transfer the data. So they may also not have that MAC entry. So what they will do, B will send the request to its neighbors, like the switches C and D, and C also don't have it, right? C will again send the request back to the node A and D. So node A was the initial node that requested the entry for that particular node Y, but the same request is transmitted back to node A actually. So the nodes switches A, B, C and D, they keep on like broadcasting the request again and again. It forms a loop actually. So this is called as the broadcast term, like broadcasting the request like a repeat in a repeated mode actually. So this is the first thing. Coming our when talking about multiple copies, the second issue, which is like if a node X transmits a frame to switch A, the switch A will forward the frame to the to its neighbors, which is B and C, and the switch B, it will send the frame to switch D actually. So switch D, what it will do is in its MAC entry, it will record the detail corresponding to that particular port, like in the port connected to the node B, I got a frame with the source MAC address of X. So then again, the node C will also transfer the data to the switch C, will also transfer the same frame to switch D. At that time, switch D, what it will do is again it will just update its MAC address table, like in the port connecting the switch C, I got a frame for which the source node is it will just again record the MAC address table, like MAC address of node X in that particular entry. So two entries for the same MAC address is recorded in the routing the MAC address table of switch D, so which is faulty. So this is called MAC address thrashing, like filling redundant entries. So in order to avoid all these issues, there is a new concept called the spanning tree protocol, and the main aim of this spanning tree protocol is just to avoid these loops and this multiple copies and the MAC table thrashing. It mainly achieves it by, for example, if initially the node B has transferred the frame from node X, like the switch B has transferred the frame from node X to switch D, and the switch D has written its MAC table entry, like from the port connecting the switch B, I just got the node frame with the source node as a source MAC address as an X MAC address. Then again, when the same frame is getting transmitted from the switch C to switch D, it will just check its MAC entry and it will see that the same MAC address entry is already stored in its MAC entry. So it will just discard the frame from node C. So but in this way, looping can be avoided. The next concept is a digital subscriber loop, or DSL. It can also be called as a DSL, digital subscriber line. It is mainly used in broadband network actually. Previously, when we were using broadband network to access the internet, either we can use the internet or we can make a call using our landline, but we cannot both access the broadband as well as landline phone at the same time. But with the help of DSL, we were able to solve this issue. But now with the help of DSL, DSL uses DSL splitters actually to split the channel into multiple different frequencies in order to avoid interference actually. So with this DSL splitters, we were able to achieve efficiency, using both the internet as well as the landline phone at the same time. There are two types of DSL actually, which is a symmetric DSL and asymmetric DSL. Symmetric DSL is mainly used in office setup, while in symmetric and asymmetric, the difference is that in symmetric, the upstream and downstream will be having the same speed actually, but in asymmetric, upstream will be very low, 1.5 1.5 Mbps, and downstream will be 20 Mbps, because in home network we will be downloading more data than uploading data. So for home setup, asymmetric DSL is used, and for office setup, symmetric DSL will be used, because office in organization, the upload and download rate will be more or less equal. That's what. So in this video we have saw about MANET, then the types of MANET, we discussed. Then the network topologies, which is the bus, star, ring, etc. Then we saw about the identifiers, unique identifiers in the network, namely MAC address, then host name, ARP, RERP, etc. Then we discussed about the redundancy issues, like how spanning tree protocol is used to handle such issues. Then we discussed about the DSL, digital subscriber line. In the next video we'll be discussing about scrambling and coding actually. So that's all for this video. Thank you.